Today you're going to learn about solubility rules and types of chemical reactions. So go ahead and turn to this section in your notes. I believe it is on page 4. First, we're going to talk about solubility rules, and then we are going to discuss the 5 types of chemical reactions. First of all, when we have an aqueous solution, so think back to the very first day of this unit when we learned about how to write chemical reactions, we learned about how to put in the different states of matter. One of those was aqueous. So when we have a solution, there are two components to that solution. We have the solute and the solvent. The solute is the substance that is being dissolved. The solvent is the substance that is doing the dissolving. Now, typically, the solvent's going to be a liquid, but really, honestly, a solvent can be anything. However, in chemistry, especially with chemical reactions, we're mainly going to be dealing with aqueous solutions, and aqueous is very specifically where the solvent is water. So I'm mainly going to be talking about things dissolving in water, but just note that a solution does not have to be made out of water. It can be other things. But again, mainly going to be talking about water. So, for example, copper 2 sulfate in the solid form, when we mix it with water, the copper 2 sulfate is the solute, the water is the solvent. Together, they make the solution. So before we mix them together, we have a solid copper 2 sulfate, and we have a liquid water. Together, they make the aqueous CuSO4. So that's my solution. The fact that copper 2 sulfate will dissolve in water means that it is soluble. So a substance that can dissolve in a solvent is soluble in that solvent. So specifically for water, when something can dissolve in water, it is said to be soluble in water. So for example, Alka-Seltzer will dissolve in water. It fizzes up. Also, soluble fiber, there's 2 different types of fiber. Soluble fiber helps slow down digestion and gives you that full feeling. And there's some examples down here as to what soluble fiber is, like examples of some soluble fiber. An insoluble substance is something that cannot dissolve in that solvent, again, specifically water. A common example you might hear is oil does not dissolve in water. And then insoluble fibers found in foods such as whole wheat and whole grain products, that adds bulk to your diet and helps with constipation. So you might hear of people using fiber to help keep them regular, but it's insoluble fiber that they use for that, not soluble fiber. Right, anyway, that was a little aside about fiber. Back to solubility specifically. We have a set of rules, and there is a chart in your notes, and here it is again. Oh, I forgot to clear off something I was practicing before. This eraser is teeny tiny. Anyway, so this chart is in your packet. It's a little bit different though, and I'll talk about those differences in a moment. But across the top, we have all of the cations or metals. So we're mainly going to be looking at ionic compounds dissolving in water here. Down the right hand or the left hand side, we have all the anions, or sometimes even nonmetals. Okay? So let's talk about these differences. So this chart is going to actually be provided on any test or quizzes. You do not need to memorize it. However, it's only going to list the ions, not name them. In your packet, you have the names next to all of these ions, but here I only have the ions. This is the exact chart I will be providing on any test or quiz. Again, you don't have to memorize any of it. You just need to know how to read it. So a couple other disclaimers, and then we'll get into some examples. The term insoluble is actually a relative term. Substances that are insoluble in water still actually dissolve ever so slightly. So our example of water and oil, the oil, while it's said to be insoluble in water, a very teeny tiny amount of it does actually dissolve in the water. But because it's less than 0.1 per mole per liter, it is considered to be insoluble. Now, you don't really need to know what 0.1 mole per liter means. That's a later unit. We'll talk about that later. But yeah, again, these are just disclaimers. You don't have to really worry about it, but just know this. All right, so let's do some practice. So Sodium acetate, my first one. So sodium is Na with a +1 charge, and acetate is C2H3O2 with a -1 charge. Together, they make the formula NaC2H3O2. So let's go back to the chart. Sodium is located right here, and acetate is located right here. Where those two things match up is right here at soluble. So a sample of sodium acetate would dissolve in water, so that is soluble. Let's look at silver chloride. Silver is Ag with a +1 charge, it's always +1. Chloride is Cl with a -1 charge, so together they make the formula AgCl. So I'm going to go back to the chart. I'm going to erase that. There we go. Now, silver is right here, Ag +1, and chlorine is right here. So where they match up, oh look, that one's insoluble. So that means that sample of silver chloride is not going to dissolve in water. We consider it to be insoluble. All right, let's look at the next one. Ammonium nitrate. Ammonium is NH4 +1. Nitrate is NO3 -1. Together it's NH4NO3. Flipping back to the chart. Ammonium is right here. Nitrate is right here. Oh, look, soluble. Calcium sulfate. There's the chemical formula. It shows you what the ions are. Calcium sulfate. Calcium is here. Sulfate is down here. We look at where it brings together. Insoluble. Then we have another set of examples. Lead 2 carbonate. There's the chemical formula. Lead is right here, Pb +2, lead 2. Carbonate is down here. So together that is insoluble. Barium hydroxide. There's the chemical formula. Remember to put parentheses around your polyatomic ion, otherwise you're changing the formula of the polyatomic ion. Barium is in group 2. Hydroxide is right here. So if we look here, oh, wait, there's a lot of writing here. That's because the hydroxides are kind of a mix with group 2. Strontium and barium with hydroxide are soluble, but calcium, beryllium, and magnesium are insoluble. So since we were looking at barium, this substance is soluble. Just a couple more. Iron 2 sulfide, there's the chemical formula. This is one that it reduces down. So iron 2, if we look across the top, you'll see that there isn't anything specifically with iron, so you can assume that it's under the others. Okay, so iron 2 sulfide, there's sulfur or sulfide, and that is insoluble. And then cobalt 3 chloride, last one. If we look over here, cobalt, again, is like iron where it's not specifically listed, so it's under others. And we were with chloride. The others with chloride are soluble. All right, so that's how you read the chart. We'll talk more about what this applies to later when we talk about precipitation reactions, which is next class. So the last thing that we're going to talk about are the 5 basic types of chemical reactions. So the first type we're going to talk about is synthesis. It's also called combination. This is when 2 or more elements or compounds combine to form one compound. So you have 2 or more reactants combining to form one product. This is usually exothermic, and an exothermic reaction means that it is releasing energy, typically in the form of heat, but sometimes light. So that's the general form. An example of a synthesis reaction, There are actually two right here. This first one, we have iron combining with oxygen, forming iron 3 oxide. That's the formation of rust. This first example right here is showing you how rust is formed. Typically, you need a little bit of like water or something to help facilitate and break down that iron just a little bit to allow the oxygen to react with it. Another example is here's where we have two compounds reacting together to form a third compound, a new one. Okay, but both of these are synthesis reactions, and that is evidenced by the fact that there is only one product. The next type of reaction is decomposition. A decomposition reaction is the opposite of synthesis, where in synthesis we had two things combining to form one. In this we have one thing breaking down into two, or more, really. Often, decomposition reactions require an energy source as an initiator, so it requires a little bit of heat or light, maybe a spark somewhere. These energy sources, like I said, they can be heat, light, or electricity. These are usually endothermic reactions, which means that I don't know why it says releases here, let me change that real quick, means it absorbs heat. Okay. The general form is AB breaking down into A plus B. Here are some examples. First of all, we have NaN3, which is sodium azide, breaking down into sodium and nitrogen gas. So it's one compound breaking down into multiple elements. This one we have a compound breaking down into a compound and an element. And this one we have a compound breaking down into two simpler compounds. Okay, but again, decomposition reactions are evidenced by the fact that there's only one reactant. The next type of reaction is called single replacement. In a single replacement reaction, a metal will replace a less active metal in an ionic compound, or a nonmetal will replace a less active nonmetal in a, I don't know why that says covalent compound. This can honestly be ionic or covalent. All right, so metal replacement, we have here where A is a metal. In the formula BC, B is going to be the metal, because remember in ionic compounds, the metal is always listed first. So A replaces B, that's why B is by itself, and now A is paired with C. Here we have a nonmetal reacting with an ionic compound. Typically a nonmetal is listed second. So in this, A kicks C out, so A is now with B, and C is by itself. So here's an example. This one is metal single replacement, because calcium is a metal. It's replacing the sodium in sodium carbonate, because these are most similar. They're both metals. And this forms calcium carbonate, and sodium, it's not actually aqueous, it is solid. And I remember that there was this typo, and I forgot about that. I knew this typo. The other ones I was not aware of. So, yeah, sodium would be a solid here. Okay, so it's an element plus a compound forms a different compound plus a different element. So you're looking for, people are switching who they're paired with. I went backwards. Whoops. All right, the fourth type is called double replacement. In this, you have two ionic compounds where the cations change places. So my general form, we have A and B reacting with C and D. So what ends up happening is A and C switch who they're paired with. So now C is paired with B and A is paired with D. Here's an example of of a double replacement reaction. The silver in the first compound and the sodium in the second compound end up switching who they're paired with. So now silver is with chlorine and sodium is with nitrate. Okay, and we'll talk more about these double replacement reactions next class, because that's what precipitation reactions are. All right, and then the fifth and final type of reaction is combustion. So, in a combustion reaction, we're going to have an organic compound that contains carbon, hydrogen, and sometimes oxygen that's going to react with oxygen gas to form carbon dioxide and water. So the general form is A, where A is really going to be some sort of hydrocarbon. So I'm going to say CXH1 Y, where X and Y are the subscripts. Let me change that back to purple and bold it. There we go. That's reacting with carbon dioxide, with oxygen gas, forming CO2 and H2O. Okay. The way you know something's combustion is you have this like CH substance reacting with oxygen gas, and these are always the products, no matter what. Here's an example. C3H8, which is propane, reacts with oxygen gas. You might need to add a little bit of a spark to get it like burning, and then it forms carbon dioxide and water, and combustion reactions are always exothermic. While you might have to add in a little bit of energy to get it started, it releases a ton of energy. That's why we burn propane for fuel, because we get a lot of energy from it that we then can harness to, heat our stoves or whatever. Okay. I believe that is, yep. All right, so that is the end of this lesson. So make sure you're taking down detailed notes on this. You can always rewatch this video and now use this information to work on the worksheet.